Counting double-digit thousands stacks.
We ensure that there is a proper mechanism and a process for tracking and controlling all the changes that we put into a software product. So that process is what we call it as SEM. So what does this SEM helps us? Now, rather than we storing all the files into some place, we can put all the files and store it into the SEM process, for which we will be using a tool. So in that way, we will store everything and we will have a complete tracking of what change was done, when was done, who did it. Every information will be available. So that is what we call it as tracking. So tracking means at any given point of time, we can easily identify and know who did what and when they did. So every information will be easily available and we can track and we can compare. And second thing is control. So that's what I said. SEM is a process of providing a methodology to track and control all the changes that goes into a software development. So what is the control that you want to give? Now, for many purpose, a user might have to only see the code, but he doesn't have permission to do the modification. Let's say in some scenarios where there is one product which is dependent on other product. Like this, there might be some common set of components which will be shared across different projects, but they don't want to do any change on that common component. So in that way, certain groups should be given access to work on certain projects, whereas other users might not be needing the access, whereas they just need only to have a read-only permission. So when I say read-only permission, it means you should just be able to see the files only for reading it and not to do any changes. That's what we call it as read-only permissions or read-write permissions. So like this, how do you ensure you have a controlled environment on who should be able to read all these project files or who should be able to read and write the contents into the project? So those kind of control permissions can be also done using this SEM process. So that is why SEM is quite important. And when we are focusing on the DevOps culture, if you look at the end, after all the tools that we go through the course, there will be many changes that we will be doing. And it is not just a developer who will be writing a code. We being a DevOps engineer, we will also be writing some kind of scripts. We will have to write some documents, some small tools. So for all these things, where is that you are going to store everything? So once again, we will be storing all these things into this SEM tool. So that is why in the DevOps culture, almost each and every engineer will be using this SEM process to store some kind of files. Because as a developer, they will be trying to store the programs which is like C, C++ or a Java program. But we as a DevOps engineer, we will be writing some automation scripts or some tools which will be storing. The QA engineers might write some documentation or some test scripts which they want to store. So like that, there will be many files that we want to change. So all these can be easily tracked into SEM, and that is why we will be using this across various levels of automation at different levels of our software development process. Okay, so that is the importance of SEM. So as I was saying, SEM plays a vital role in DevOps in storing some kind of file. One thing that you need to know is majorly in the SEM tools or through the SEM process, we basically maintain only text related files or text files. So we don't store a binary file and maintain. So majorly any file which has content in form of text will be stored into the SEM tool and maintained. So in that way, there are different tools available in the market using which you can achieve the SCM process. So among that, if you look, since we are focusing on the DevOps way of working, we need things to be done faster, and we need to automate whatever process that we are working in which it should be easy and simple for us to do the task, and at the same time maintenance should also be very easy, because as in DevOps you don't just focus on only the development, we also focus on the maintenance and the system requirement. So that is when, if you use different other tools that is available in the market, which are basically licensed tools, think about ClearCase, Perforce. So all these things are huge tools which will serve the problem for an organization in terms of SCM processes, but you have to buy license and maintain it, and it requires a huge effort in maintaining and the system requirements. So that is when people started using open source related tools, because it will help you to reduce the cost as well as simplifying the process. So in that way, in the beginning, people started using a tool called Subversion. But over a period of time, Subversion again had its demerits in terms of maintenance and automation, which was not so easy. I mean, it doesn't mean that Subversion, we cannot do automation, we can still do it, but it would take some more effort in doing the maintenance and automation. So that is when they came up with a tool called Git, which served all the purpose. That is, it is an open source tool. By saying it, you don't have to pay anything for that. So it's freely available, which you can download and start using. Second thing is, it's easy to set up and it is lightweight. So when I say lightweight, you don't have to spend too much of effort in installing and configuring, as well as it doesn't require too much of system requirements. It's quite simple and lightweight. And then it is easy for doing the maintenance. So that is the reason, because of faster way of doing the operations and better and efficient way of doing the automation, people started using Git as one of the important tool to achieve the SCM process as part of the DevOps culture. Okay, so this is what we are going to see in the very first module. So SCM is our first module, and in that we'll be going through this version controlling tool called Git. So basically, what is Git? Git is a SCM tool or a version controlling system tool through which we will be able to write some code and store into it. Okay, and we will be able to track it. So in that way, what is the major reason why people started using Git? So to understand that, these are the 4 major advantages because of which Git is quite popular. First thing is speed. So if you have worked on any other tool, you will start comparing and see the difference on Git, because it will be very fast when compared to other tools. So whatever actions that you want to perform, you will be doing it pretty much in a faster phase using Git. Second thing, so in Git, you will be able to do non-linear development. That is, there is a concept called branching, which we will see it later. So that concept can be done in any number using Git, whereas we have the limitation on working on the branches on other tools. And third, Git is not just an ordinary SCM tool, but it is a fully distributed SCM tool or fully distributed version controlling tool. Okay, and then even if you have huge projects, it's easy for us to handle and maintain in Git. Okay, so these are the major 4 advantages on why we will be working on Git. And in fact, whatever tasks that we are going to do, you will be able to see that we are working based on these features only. Okay, so before we get into the Git, let's spend some time and understand certain common terminologies that we use in software configuration management or version controlling. So now, let's try to understand that using some diagram. So now when you work on a tool, so I'm not talking about Git now, but I'm talking about a generic SCM tool. Okay, so in any SCM tool that you take, basically there will be first a server. Okay, and in this server you will be actually storing all the files, whatever that we are trying to develop and maintain. Now in that, if you look in an organization, you are not just going to just work on one project. So there will be several different projects on which we will be working. So in that way, are you going to dump all the files of all the projects into the single server? No. So basically, when I say a server, it is nothing but a machine on which you're going to store all the files, and that will be maintained by your SCM tool. So now in that way, how is that you are going to store the files separately? So for that, what we will be doing is basically we will be segregating the projects and its file, and based on this segregation or grouping, we will be storing everything as a group into this server. So in that way, here inside the server, we will be having something called as repositories. Okay, so a repository is nothing but a container inside a server in which you will be storing files specific to a project. So like that, a server can contain many repositories. So let's say this is repository A, where this pertains to a product called A or a project called A, and all its file or all the related file for this project will be stored in this repository. So going forward in terms of SCM, when you're referring to a project, you will always refer to the repository of that project. So like this, we can have as many projects that you want inside the server, wherein remember each repository is specific to one particular project. Okay, and these things are called as repositories. Okay, now the next thing what you need to know is anything that you store specifically in a repository is known only to that repository. So in that case, now let's say I store a file called 1.java in this 2.java. Now whatever changes I do to this will be known only inside this repository. Now if I create a file called 1.java here, this doesn't mean that both the files are same, because anything that you store inside this container will be stored and maintained only within this repository or container, and if you come out of that, it will not be knowing anything to it. So that is how anything that you store inside a repository of that project will be specific to that project. Okay, remember this. So now when you want to work, this is the place where you store, but as a user, how is that we will be accessing? So that is when there will be a client. So when I say client, the client is basically a software or a tool. That is what the actual SCM tool is, which will be on your machine or laptop through which you will be trying to access, right? So now let's say this is the client. So in the client, how is that you're going to access a specific repository of a project and work? So now in the client, you will be creating something called as workspace. Okay, where a workspace is nothing but a simple directory. So now why do we need this workspace or directory? Now as a user, when you want to do some changes or development, you should be able to see the content of these repositories so that you can do the changes and store it back, right? So in that way, in the client, we will create a workspace which is nothing but a normal folder or a directory in any machine, and inside that you will be seeing the contents of a particular repository. So suppose if you want to work on project A, then you will create a separate workspace, and that will be referring the repository A, so that this content will be visible here. Suppose you want to work on B, then once again you create one more workspace, and in that workspace you will specify with the help of the client what is the repository on which you want to work. So like this, each workspace will be a directory. Inside that you will be able to see the content that is being stored in the server, and in this workspace you will do the change and you will store it back. Okay, so the process through which you will be able to see the content inside this workspace is what we call it as a checkout. Okay, so a checkout is nothing but a process where inside your working directory or the workspace, you will be telling to the server through the help of client on what is the repository that you want to work, and in that what files that you want to see inside the workspace. Okay, so that is exactly what we call it as a checkout. So whenever as a user, when you want to work, you will create a workspace, do the checkout of a particular repository through which you will be able to see the contents inside the workspace. Then after you see the changes, you will be doing some modifications, and then once you have done the modification, when you want to store, you should store it back to the server in the specific repository, right? So how will you do it? So that step where you do the changes and store it back to the respective repository is what we call it as check-in. Okay, and in terms of Git, we call it as commit. So check-in or a commit is nothing but a process where we will try to store back the changes to the repository. Okay, now every time a person does a checkout, he will be able to see the contents, and after doing the changes he will do a check-in or commit so that it will go back and store the contents, right? When it is storing the changes back to the repository, with respect to that repository where he is doing the check-in, it will be creating some reference. So with the help of this reference, we will be able to exactly say who did the change, when he did, what is the change that he did. All those information will be clear in it. Okay, so now if one person does some change and he does a check-in, there will be a reference created, and then if another user does a change, it will create another reference. So like this, for each repository there will be a reference created, and it will be stored in the specific repository only. That means a reference that is created because of a check-in or a commit in a repository is known only to that, and these references using which we will be able to track on which user modified, what exactly he modified, and when it was modified, and these references is what we call it as version. Okay, so these are called as version. So now if you see, this is the reason why we call the SCM tool as version controlling tool, because whatever that you are going to store will be in terms of versions, and in Git we call it as a version or we also call it as a commit ID, wherein commit ID is nothing but a unique number using which you will be identifying what was the change done and who did it and when it was done and by whom it was done. So all those information will be tracked here. Getting it on what is a repository, what is a workspace, what do you mean by checkout, check-in, and version or commit ID?